I only wrote it twice before, so. Today. Okay, so we are back to 3.9. We are looking at problem 27 on 249. And we have a cone in which we are told that forever in this cone, we have the height always the same and equal to the diameter. Let's read the problem one more time. Gravel is being dumped from a conveyor belt at the rate of 30 cubic feet per minute. What does that mean? What does 30 cubic feet per minute means?
30 cubic feet of gravel.
Yes, what does this represent? I have to write something that is this number. Very good. dV over dt. It's a measurement unit for the top, measurement unit for the denominator. We can't miss that, right? If it's cubic feet per minute, it must be dV over dt. Perfect. Well done. Now we're told that the diameter and the height are always the same, which means the diameter, which is 2 times the radius, is always the same with the height. How fast is the height of the pile increasing? When the pile is 10 feet high. What is that? How fast is the height of the pile increasing when the height is 10 feet high, or the pile is 10 feet high? Over? Exactly. This is what we're asked to find. Excellent. Please remember that this is always, and I have to put it in the problem from the very beginning, this only at the very end. Do not include this anywhere. Don't cross it out like that, but you know what I mean. I'm making a point.
What h that's equals to
the diameter, twice the radius. Okay. Good. Where is our starting point? So let me refresh your memory how these related grades problems have to be addressed. At least 2 functions of time are involved, maybe of time or something else, but these 2 functions must be involved in an equation. So I have to look for an equation that involves 2 functions. Then I will differentiate both sides of that equation to get an equation that relates their rates. So initially I have an equation that relates the functions, no derivatives. But then when I differentiate both sides, I create an equation that connects not the functions, but their rates of change. When I'm done with that, I will solve for what I'm interested in and then plug in the numbers. So step 1, I look for an equation that relates what I'm given to what I'm asked. Then I create an equation that will have not the functions in them, or maybe even the functions, but I'm interested in the rates of change. And when I'm done, I solve for what I'm interested in, and then I plug in all numbers that are needed to be plugged in. So then, in this particular situation, I will have to come up with a relationship, an equation that relates this to this. Volume of a cone, yes. Yes, pi r squared. So let me just refresh your memory. So here's a cylinder. This is the easiest way to remember them by comparison. So let's say the radius of the cylinder is r, and let's say the height is h. So the volume of a cylinder is the area of the base, pi r squared, times the height. All you have to remember is that the cone is identical, but it has 1/3 in front. So if you remember the volume of a cylinder, you will always remember the volume of a cone. It's only because it has 1/3 in front. This has nothing to do with our problem. I just wanted to show you how to remember the volume of a cone by comparison to the volume of a cylinder. Okay, so you can forget about this now. Good. So I have age, of course. Sorry. So 1/3 pi r squared h. Good. So I have the volume on one side. I have the radius and the height, but I'm interested in the height and I don't know much about the radius. So of course, I'm going to replace the radius by h over 2 in here. So r squared has no place in there. I know nothing about r. I will connect the volume to the height, and I don't care about anything else. And that's why I'm given this information by simply replace r by h over 2. And now I have a function that is indeed function of one variable, in this case, pi over 3. Radius will be h squared over 4 multiplied by h. So then the volume will be pi divided by 12 h cubed, which is quite a simple equation. So this equation relates the two functions in question, the volume and the height. The volume is a function of what? Time. And the height is a function of? Correct. Good. So then we are ready to do what? Very good. So we differentiate the left-hand side. What do we get? That's it. We differentiate the right-hand side, 3 times the height to which power? Times right. That's why we said from the very beginning, before we even differentiated, v and h are both functions of time. Good. So I'll simplify. And I will solve for what I'm interested in. So dh over dt equals this over this. dv, do not separate dv over dt. This is the derivative of the volume with respect to time. And the denominator, it will be pi over 4 times h squared. And now you can plug in anything you want. So you understand that when we are using the notation dh over dt, it's not like f prime of 10, right? F prime of 10 is very simple, very clear, I should say. I'm evaluating the derivative at 10. But in this case, I can't do that. So I draw a vertical line, and I write when h is 10. I think it was 10, right? Yes, 10. So I have the numerator, and also be very careful with the measurement unit, right? So the numerator is measured in 30 cubic feet per minute. And h is also given in feet, so we are on the right track. And that's 100. So I will simplify. And then I flip, and I get 12 divided by 10 pi. Or 6 divided by 5 pi. It doesn't matter, I have to approximate it. Be careful how you plug it in, because you have an option as 6 divided by 5 and further divided by pi, if you do not do this, then you have to have 6 divided by parentheses, be careful, 5 pi. They're not going to be the same if you do not use parentheses in the denominator. Okay? So it's 6 divided by 5 times pi. You perform 5 times pi normally, and then you divide 6 by that number. Or you divide 6 by 5 and you further divide by pi. Otherwise, you will not get the correct answer. So I will write 0.38. It means nothing without a measurement unit. So what is the measurement unit for this? Careful. Look at what we are determining. Feet per minute. Is that clear? Yes? So it is feet per...
Dr. Myers said something.
What did he say?
Whenever you're wrong, careful.
I see. I didn't know that he was using the same strategy. Sometimes I say no, but then I think, maybe that's too harsh, and I don't really mean to say no like that. I just get carried away sometimes. I apologize if that ever happens. It's not intentional. Trust me. Okay. Any questions on this problem? Do we feel a little bit better about related rates after this one?
Could you
Yes.
You had a mental process you went through, and I was able to write the first step.
Yes. Let's write it together. Right?
Yeah.
So for any related rates, I do this. Number one, I read the problem at least twice and make sure I take the notes, like 30 cubic feet, what I'm asked to determine. So read it. Read the problem. Take notes. Maybe draw a figure. Not just take notes. Draw a figure, a measurement unit, etc., etc. So draw a figure. Take notes. I may even, after that, I may even go back and make sure that I didn't miss anything and read it again. And then I try to find an equation that relates the functions in the problem. In this case, it was volume and height. These were functions, both were functions of time. So I try to create an equation that connects these two functions.
By that you mean like where you were substituting
The volume, the volume equals 1/3 pi r squared h. That's the equation that relates volume to h.
is the next step, the part where it's like a volume function, where you're taking one variable from one formula and replace you're trying to do
Oh, because I was given, yes, I had 3 variables basically. I had r, I had h, and I had v. But I wasn't given any information about r, so I really needed to get rid of it. Yeah. Because if I don't, then I have, in this situation, even the radius changes. So then when I differentiate the product on the right-hand side, I have to use the product rule. But then I will end up with dr over dt that I know nothing about. I couldn't replace that by anything. So I needed to eliminate and keep basically just the volume, because the volume I knew everything about. I knew the rate of change, and I needed to keep h because I was looking for dh over dt. Everything else in between is noise, and I want to get rid of.
Or only able to do it because the problem set it up so that age
Yes,
equal.
he was telling us that happened always. If he had said, find the h over dt at the instant in which height equals radius, would have been a different problem. I could have not used that information from the very beginning. because that did not happen at the same all the time. It happened at a particular instant. So that was an information that I had to use to wait to use till the very end. I could not do anything in between with it. But in this case, I was given a relationship, so I could get rid of radius. But that's not going to be the case all the time. That's why I didn't put it here. So once I have the equation that relates the functions in question, I differentiate the equation implicitly. 5, solve for the unknown. Only 6, the very last, plug in. Only at the very end I plug in numbers. Questions?
Thanks for going back over that.
Say it again.
So thank you for going back over that.
Oh, is that better?
Yes.
Okay. So, yes, problems, this is the core, but there may be some variations depending on the problem. Okay? Okay, so I'd like to look at this. Okay, so we have two cars start moving from the same point. One travels south at 60 miles an hour and the other one travels west. So something like this. Right? At what rate is the distance between the cars increasing 2 hours later? So one goes south at 60 miles an hour, the other one west at 25 miles an hour. How fast is the distance between the ships? I'm sorry. How fast is the distance between the cars increasing 2 hours? I skipped. I looked there for a moment. Increasing 2 hours later. Okay. I'll draw a figure. I kind of have an idea of what's happening here, but I still have to draw. So this is 15 on page 248. And one car is moving south at 60 miles per hour and the other one west at 25. And so at some point in time, the distance between those two will be this. I'm going to call it W. I cannot use D because it will be DD and I don't want to do DD. Right? So we're going to use W, let's say, or any other letter, not D for distance. Okay. But what am I asked again? Right. Is that clear? Perfect. We're asked to find the W over dt exactly 2 hours after they start moving. One going south and the other one going west. Okay. So obviously I'm going to call this distance x. I'm very careful now. And I'm going to call this distance y, not x. Because vertical is y and horizontal is x. Somebody warned me. Okay, so then, is there anything? So obviously I have to relate this w to what I'm given. So this is a function of time, this is a function of time, and this is a function of time. So what does 25 miles per hour represent? And what does 60 miles per hour represent? So what is 25? Exactly dx over dt. And 60 miles an hour is? Right. So if I manage to come up with an equation that relates x, y, and w, well then this will be right? So I read the problem, I draw a figure, I took notes, I will find an equation that relates what I'm given to what I'm interested in finding, and then I will differentiate that equation implicitly. And then I'll solve for the unknown. Can anyone give us an equation that we could use here? Yes, of course. How do I write it? Excellent. Indeed, the Pythagorean theorem, x squared plus y squared equals w squared. Excellent. And now I'm ready to differentiate. I found the equation that relates the given information to what I'm interested in finding. That's really all I need. And now I will differentiate. Ready? But now remember, x, y, and w are what? Of? Excellent. Good. So I'm ready. Excellent. That's it. Of course, I will divide all three terms I meant to say by 2. So I have x over dt plus y dy over dt equals w dw over dt. So we divided everything, each term by 2. So now I have dw over dt equals all this x dx over dt plus y dy over dt divided by
2.
Is that clear? I'm solving for this. So now they are telling us when t equals 2. But you can say, wait a minute, you haven't found the rest. Your t equals 2 is not even here. True. We will find every piece step by step. Okay. So I'm going to start with the most difficult part. No, it shouldn't be. I shouldn't say difficult. The more cumbersome part with this. But I know this is the square root of this. When I apply square root to both sides, I get the w. And then the top is still this. Okay, let's try to plug in the numbers we have. Okay, so let's go back to the drawing. Where's my drawing? Okay, right here. Okay, so we know that dx over dt is 25. We know that dy over dt is 60. But now I have to find x and y. X, y, x, y. Once I have x and y, it's done. Yes. How do I determine x? Exactly. Now I'm ready to plug in numbers. So how much is 25 times 2 hours? 50. So this is 50 miles. And then this is 2500. How much is y? 120. Very good. So if that's 120, this is 120 squared. We have to be very careful how we plug everything in. So let's do that with a calculator. Please put parentheses around the numerator. Mandatory, please. 50 times. Maybe it works without if you have a sophisticated calculator. I shouldn't say. Okay, plus 120 times 60 and divide by the square root. I always put parentheses. In some calculators, the parentheses pop up automatically. In others don't, so it's up to you. So plus 120 squared, close the parenthesis, and now hit enter. Measurement unit, please. Miles per hour, of course, it's distance with respect to time. Excellent.
One confusing point, where did you get the two, where you multiply x and y by two?
T equals 2?
How?
It's in the question. 2 hours later. How fast is the distance between the two cars changing at that instant? Exactly 2 hours later after they start driving. Is that okay? Yes?
In this instance, dx over dt is the original value. Which was,
Yes, 25. That doesn't change.
Yeah.
Although you,
That's what I was trying to figure
Although-
out, so where'd that number come from?
although you know that we are making an assumption here that there is only uniform motion. That's an assumption, right?
Right.
Well, we can't really drive at all times at a constant speed. So that's the assumption, that there is only uniform motion here. In other words, that 25 miles an hour and 60 miles per hour never change on this trip. Not feasible, right? You still have to start from 0. So you can have 60 miles an hour, drive 60 miles per hour at all times. Even if it takes you 6 seconds to get to 60 miles per hour, if you have the supercar, or 4 seconds to get to 60 miles per hour, you still have to start from 0, and that's not uniform motion. You need acceleration to do that. Yes, right.
So 65 miles per hour is the distance.
The rate of change,
Yeah, the rate of change.
the distance between the two
So
cars,
just at 2 hours.
exactly 2 hours after they start.
If you want 3 hours.
Then you have to put 3 hours.
So you multiply the rate.
Yes, yes, and everything changes because the distance will change. X and Y will change. After 3 hours, the distance is different, and the denominator will change, but not the rate of change of each. Ready for the next one? Okay, so we looked at the motion. We looked at a cone. Yes, let's look at 29. Let's take a look. Yes, I could use a month on this section alone. Okay, so in 29 we have two sides of the triangle. They are 4 and 5 meters respectively. And the angle between them is increasing at a rate of 0.06 radians per second. Find the rate at which the area of the triangle is increasing when the angle between the sides of fixed length is pi over 3. So we have a triangle with two sides, 4 and 5, and an angle in between those two. And we're told that the sides do not change, but the angle changes. So the angle between the two sides changes at a rate of 0.06 radians per second. That change will trigger a change in the area, correct? If If I have this triangle, but I'm changing the angle, I'm changing the area. So the angle and the area are two functions of time. Okay, so find the rate at which the area of the triangle is increasing when the angle between the sides of fixed length is pi/3. We read the problem, we take notes, we draw a figure, and think about a relationship, an equation between which variables? I shouldn't say variables, between which functions? Area and time is not a function,
Radians.
an angle. So the measure of the angle and the area. We have to find a relationship, an equation that relates the area to the angle in the triangle. And then everything is easy. So what problem is this? 29. Page 249. So we have a triangle. We are given two sides of a triangle and the angle between them. I'm going to call it theta. And we are given 0.06 radians per second. You tell me what that means. Find the rate at which the area of the triangle is increasing when the angle is pi/3. I'm missing two quantities before we even attempt to start or attempt the problem or think about the problem. What is this? Well done. Indeed, d theta over dt. And what is this? Of course. Thank you very much. Do we understand what's happening here? We don't know a formula just yet, but we will find the formula. But is it clear? So the angle between these two sides is changing. It's increasing. And we're asked to find the rate at which the area is increasing at a particular instant. Remember, this means nothing right now. Do not even look. Completely disregard it. Okay, so then we do have a formula for area of a triangle that includes the sides between two angles and the angle in between. We do have a formula. Forget about the formula. I just want to discuss how we get there. So how do I determine the area of this triangle? Because I have to determine the area, and somehow I have to connect. I have to have an equation that relates these two. If I can't find an equation that relates these two, I can't solve the problem. So omit what you see here. Just don't even look. How do I determine the area of a triangle? Exactly. So let's say this is the base, this is the height. So then the area of this triangle is base times height divided by 2. It happens that I chose this side, so I have the base. 2 is 2. The question is, how do I find the height? The height is not given. Is there anything I can do here? Is there any trig function that will allow me to determine the height in terms of theta? Exactly, thank you. Sine theta equals the opposite over? Yes. Can anyone solve this for h for us? And that's the formula. I'm just going to replace the height in here. So it's going to be 5 times 4 times sine theta over 2. So the area is 5 times 4 times sine theta over 2. that was the only trick. The general formula is this, but I don't want you to memorize it. It's easy to determine anytime. So if we have this situation, A, B, C, and we are given, let's say, A and C. These are given. And the angle in between, I'm going to call it angle B, of course. Then the area of this triangle is A times C sine B divided by 2. Exactly what we just got here a minute ago, right? So A times C times sine theta over 2. AC sine theta over 2. Of course, I'll simplify. So the area equals 10 sine theta. I found what I was looking for. I found an equation that connects two functions. One function that is the area, and the other function that is angle theta. Both are functions of time. Any questions before we continue? Any questions on how we determine this? Do you need me to go back and show anything again? Ready to continue? So we have the equation that relates these two functions. And now what? Yes, of course. Please differentiate the left-hand side and tell me what you get. Please differentiate the right-hand side and tell me what you get. Very good. Times the inner function prime. Is that clear, everyone? Yes? Okay. Since this is what I'm after, I don't have to solve for anything. It's already solved. All I have to do is plug in the numbers. So when theta equals pi over 3, this will become cosine pi over 3. And d theta over dt is given to us as 0.06 radians per second. So cosine pi over 3 is, it's the biggest angle. It has to be the opposite of sine pi over 6. 1/2. Let me show you the little table one more time. So theta, sine theta, cosine theta. Pi over 6 is the smallest. The next in line, pi over 4, or 45 degrees. And the very last one is pi over 3. 1/2, 1/2. So cosine pi over 3 is 1/2. Square root of 3 over 2, the square root of 3 over 2. And this is the only one that has the same. So the bottom angle cosine is 1/2. So this is 1/2. 10 times 1/2 is 5. 5 times 0.06 is 0.3. Measurement unit. Before you say anything else, look at what this represents and what this represents, and you will figure out the measurement unit. Meter squared per, that's it. Say it again. 10 times 1/2 is 5, and 5 times 0.03, 0.06 is 0.3. Questions? Okay, let's look at resistance. It's all about two resistors. 35. Any questions? I'm sorry, forgive me. Any questions on this? Is this okay? Once we got the equation, it was not a big deal, right? We differentiated with respect to time.
Meters squared per second.
Meters squared per second because it's area per time. Is that okay? Okay, so let's look at 35. If two resistors with resistance R1 and R2 are connected in parallel, as in the figure, it's probably on the back. Yes, it is. Then the total resistance R, measured in ohms, is given by this relationship. 1 over R equals 1 over R1 plus 1 over R2. If R1 and R2 are increasing at rates 0.3 ohms per second and 0.2 ohms per second respectively. Let's see what they want. How fast is R changing when R1 is 80 ohms and R2 is 100? Okay? Ready? Okay. We read the problem one more time. We draw a figure or not. We are given the equation. So that's one step is already made for us, right? We don't have to come up with the equation. They're telling us that this is 35. So this is a easier situation. That 1 over R equals 1 over R1 plus 1 over R2. We are told about R1, 0.3 ohm per second and 0.2 ohm per second. What does the first one represent? dr1 over dt and dr2 over dt. And we're asked to determine when R1 equals R1 is 80 and R2 is 100. But what am I asked to find?
dr over dt.
Exactly, dr over dt. This is our question. Remember, this has to be completely disregarded till the very last step. And I'm ready when you are. What do we do? Yes, I know. Like all my students, not all, but many. Calculus, easy. Algebra, very difficult. So, no, what do we do?
One over.
Say it again. Yes, yes, yes. I will do this, of course. You will never force me to differentiate those fractions. You can't. Well, this is so much easier. Okay? We have the equation. We don't have to come up with the equation. We have everything. I changed it into simply something to a negative power. Doesn't matter. Same thing. And now we are ready to differentiate. All these are functions of time. Good. So let's differentiate. -1 r raised to, good, not enough though. That's it. Equals. I shouldn't put plus because it's minus. The same thing, dr2 over dt. Good. Perfect. Okay, so now what I have to do is solve for the r over dt. I change everything into positive by multiplying everything by -1, and I divide by this. So dr over dt equals r1 to -2 dr1 over dt plus r2 to -2 dr2 over dt over r to -2. Because we're plugging in numbers, it doesn't matter, but I have to be very careful when I put everything in the graphing calculator. Because those, if I omit everything or anything, then everything collapses. Okay. I have this. I have this. I have everything except this. We're going to determine in a minute. So what was dr1, I think is 0.3. Yes, so this is 0.3 and this is 0.2. This I know is 80 to -2, careful. And this is 100 to -2. But now I have to come back here. I have no choice and solve this for r with 80 and 100. So I can plug it in here because I don't have this. So 1 over r equals 1 over r1 plus 1 over r2. Or 1 over r equals 1 over 80 plus 1 over 100. What I would have done instead of working on this and find the LCD, etc., I would have done this. 1 over r equals r2 plus r1, or r1 plus r2 over the least common denominator, and then just flip. Instead of worrying about this. So then r equals 80 times 100 divided by 80 plus 100. Should I show this one more time? Is it clear? Okay, perfect. So I will simplify a little bit. So I have 800 over 18. I can continue simplifying it. So r equals 800 over 18. But that's good enough. I just need it in here. But now we have to be very careful how we put everything in the graphing calculator. Let me know when you're ready. Randy, any question?
Where's the 180 come from?
R1 plus R2, 80 plus 100. Because I flip this and I flip this. In a proportion, only in a proportion, I'm allowed to flip both. And it's still a proportion. Or cross multiply, it's the same thing. Ready? Okay, have to be very careful. So left parenthesis for the top. We have 80 to power, you know me, I have to put parentheses on that -2. I don't know if it's required. I don't know if the calculator is smart enough to do without, to handle the power -2 without. I doubt, but I don't even want to try it. I don't care for that. Meaning, I don't trust it anyway. So 100 raised to, in parentheses, still -2, and come down and multiply by 0.2. It was 0.2, yes, it was. Close the parenthesis and divide by, in parentheses, because it's a fraction and some operation needs to be performed, then I want the calculator to perform the operation first. Or not, but I have to change everything if I don't want that in parentheses. Okay, so I got .0, so -6.
Sorry, 800 divided by 18.
Yes. Oh, I forgot the -2. Yes, thank you. See, that's me. I had to forget something.
Did you hit your 1 hour mark for your video?
Yeah, because I didn't put it here. See, I put it here. I put it here, but not here. So that's why I forgot. No excuse, no excuse, no excuse. Sorry about that. It seemed like a tiny, so yeah. So equals, okay. 0.1321. So dr over dt in those conditions, 0.1321. Measurement unit, please. Thank you. Excellent. Did we get the idea? I know it's far from over, but did we get the idea of related rates? Initially, they looked, they seemed a little tough to handle, but yeah, of course, there are certain situations that are more involving than others. Do you think we need another example? Perfect, okay. Yeah. Absolutely, yes. So let's take 5 minutes. That's what you needed? Okay, perfect.